Section 1.8, we have two main goals. The first is to look at the arithmetic combination of functions, and the second is to look at composite functions. We won't spend much time looking at the combinations of functions for arithmetic properties, because it's a lot of the things you should have learned in algebra as far as adding, subtracting, multiplying, and dividing polynomials. But we can go through and look at the notation that goes along with this. So a few things to note, looking down here at the bottom, is that we've got this function f plus g of x. What this means is that we want to take f of x plus g of x. Really what we're doing here is renaming this as a new function. And we are allowed to put this operator of plus on the inside. So we're naming this the function f plus g. Similarly, we can go through and we can subtract f minus g, and that's telling us to take f of x minus g of x. We can multiply and just put fg, telling us to take the function f of x times g of x. And then lastly, we could do f divided by g, and then that's telling us to take f of x divided by g of x. Now up at the top, I didn't actually go through and use that notation, but you could rewrite these to be symboled as we have down here with the notation that I've written. But what I want you to recognize, a few key things to point out here, is that I'm going to have to define the functions f of x and g of x for you in a problem. You can't do f of x plus g of x if I don't actually define them for you first. Then going through and adding is just like adding two polynomials, put together the like terms. As far as subtracting goes, make sure to go through and distribute this negative to each term on the subtracted polynomial, or on the subtracted function. You can then go through and combine like terms like you did with addition. With multiplication, make sure that each term from our first polynomial gets multiplied by each term in the second polynomial. So 5x would get multiplied by x squared to give 5x to the third. 5x would get multiplied by negative 4x to give negative 20x. And 5x would get multiplied by negative 1 to give negative 5x. Similarly, 2 would get multiplied by each of the three items, and we would get the remaining three terms on this right-hand side. We can then combine like terms to get our answer for this product of f of x times g of x. Lastly, we've got f of x divided by g of x. Notice here that the solution that I've given is simply just the two polynomials being divided. I didn't actually go through and divide anything. Sometimes that will be the case when we're looking at the division of two polynomials. Later on, we'll learn how to actually divide these guys, but for now, you can leave it in this form. What you do need to recognize, though, is that we need to state the domain whenever we've got any sort of division in our problem. Remember for our domain that you can't have the denominator equal to 0. So I've stated here that the denominator, which was g of x, cannot be equal to 0.